So we have here our last example that we are going to look at, and it's saying that a smaller convex mirror is placed 60 centimeters from the pole and on the axis of a large concave mirror of radius of curvature 200 centimeters. Okay? So they are saying that the position of the convex mirror is such that a real image of a distant object is formed in the plane of a hole drilled through the concave mirror at its pole. So when we move step by step, we can first draw the ray diagram. They're saying a smaller convex mirror is placed 60 centimeters from the pole and on the axis of a large concave. And I have a very big concave mirror like this. But this concave mirror has a hole at the pole. Okay? A convex mirror is placed 60 centimeters from the pole. This is the pole. And now we have a convex mirror which is placed maybe somewhere here at a distance that I can say from here up to here. We measure distance right away from the pole, and that is equivalent to 60 centimeters. Okay? And then they're saying that the radius of curvature is 200 centimeters of this concave mirror here. The position of the convex mirror is such that a real image of a distant object is formed in the plane of the hole drilled through the concave. That the position of this mirror here is such that the rays that is coming from a distant object, how do we draw the rays from the distant object? It will be something like this, something like that, and now it will be incident here, it will be incident here. Okay? And now from here it is reflected to form the final image I2 here. But in absence of this one here would meet at a point here. That's where our image would be formed. So if the light rays come from a distant object, it is reflected. In absence of this, it is supposed to be formed at the focal lengths. Okay? Images from a distant object is formed at the focal lengths of the mirror. We saw that in our ray diagrams. So that means that the distance from here up to here where the image is supposed to be formed is supposed to be radius, focal length, which is 100 centimeters. Okay? Because if it is from a distant object, it was supposed to form its image at the focal point, and the distance from the pole is focal length. But because this mirror is there, it will reflect it, and they are saying that the arrangement or the position of the mirror is such that its final image comes at the pole of this one here, and that pole has a hole that is drilled through it. And that is exactly what they are talking about, that a smaller convex mirror is placed 60 centimeters from a pole and on the axis of a concave mirror. This is the pole, and there is an axis. Okay? The pole is here, and 60 centimeters from the pole and on the axis of a large concave mirror, isn't it? So they placed it sharing the same axis, but at a distance of 60. From the pole up where the mirror is 60. The radius of curvature is 200. And the position of the convex mirror is such that the real image of a distant object is formed in the plane of a hole drilled through the concave. That the final image is now formed in the final, what is formed in a plane of a hole drilled through the concave mirror. That they drill the hole and the image is formed here finally. And then draw a diagram to show how convex mirror forms the image of non-axial point distant object. Okay? So if it comes a distant object, that's how we draw it. reflected here and then reflected again here. But this first reflection here would result in formation of image in absence of this. And we're saying that image in reality is supposed to be formed at the focal point. So this is supposed to be focal point of this mirror, because for distant objects the images are formed at a focal point. That means that this length here should be focal length. Focal length is radius divided by 2. If we divide this by 2, we get 100, and that is the focal length. And basically this answers, this one here answers Roman 1. Okay? And then Roman 2, what they need from you is suggest the practical application for the arrangement of the mirror in A above. This arrangement is for what? Basically, as per now, we may not get it all that well because this is an optical instrument which is called, this is a reflecting telescope which is used to view a distant object. Okay, so we have not yet looked at this arrangement, but we shall look at it as we are analyzing our last topic of optical instruments. So this is a telescope and is a reflecting type, and telescopes are used for viewing a distant object. We shall analyze that if we reach there. So for Roman 2, they're saying that calculate the radius of curvature of the mirror, of this mirror here, because already this one, you know, the radius of curvature is 100. What is the radius of curvature of this mirror here? So for this mirror here, I would say considering action of the convex lens, convex mirror. For this convex mirror here, we are saying that the image, this will be its U, and basically this will be its V. Is that okay? That if the light rays come reflected from here, it was supposed to come here, but because this is there, it will reflect it to bring it here. So that means that this will act as its object, but a virtual one. Okay? Because it's not there. So this is an image for this one, but it's an object for this, and it will form the final image there. So we shall basically say our U is this value here, which is the same as 100 but a negative. 100 minus 60, which is giving us negative, excuse me, negative that. And then we shall also say our V, the image is going to be formed here at a distance which will now be 60 centimeter, but real. And now we are saying using 1 out of F equaling to 1 out of U plus 1 out of V. My 1 out of F will be 1 out of U. U, we are saying is negative 40 plus 1 out of 60. What is our LCM in that case? Our LCM here is equivalent to 120. So I shall say 120 divided by that will be negative 3 plus 120 plus 120 divided by that, we say that is negative 3 times 1, something like that. And then this one, that is 2. So that is plus 2. And then we shall now therefore say my 1 out of F equaling to negative 1 out of 120. That means my F is negative 120 centimeter. So that means that the focal length required here, the focal length required here is supposed to be negative 120. But remember, they are saying they want the radius of curvature. We shall say, but R equaling to twice F. That will mean that we are supposed to 2 times negative 1, 20, multiply this one by 2, and R is negative 240 centimeters. So therefore, the radius of curvature is 240. Okay? The negative is telling us that the radius of curvature of a convex mirror is always a negative. But when I'm concluding, I'll just say the required one is supposed to be 240, and that is acting for this second for this first Roman for part B. And now they're telling us that we should also calculate the height of the real image if the distant object subtend an angle of 0.5 at the pole of the convex. Where is the pole of the convex mirror? The convex mirror has its pole here. So if the distant object is supposed to subtend that angle, it will imply that if I have this here as my convex mirror, we know very well this is the pole. So angle subtended at the pole, we shall look at if this is the ray from the distant object and that will be reflected here. We know this one here will act as the height of the image. Okay? And now this is the angle subtended. We know that if the rays are incident at the pole, what happens is the angle will be the same. So this will be 0.5 degrees and this is 0.5 degrees. So if I'm to look at that, now they are saying that is equivalent to now this one coming up to this point here, and shall have that distance as 100. So this one here will be equivalent to 100 centimeters. Okay? That is when this one comes here. Now we are trying to look at the angle that can be subtended at the pole here. 0.5, 0.5 for that 100. So we can now say tan theta, we can say tan of 0.5 degrees equaling to opposite out of adjacent, which is 100, and my H1 is 100 times tan of 0.5 degrees. You can pick your calculator. You can pick your calculator and say 100 times tan of 0.5. That is 0.87. And I can say that is 0.87. That is 0.870 that centimeters as the height of the intermediate image. Okay, that is, we are looking at this, that in case we are to look at the distant object subtending. Okay, a distant object subtending, that if it comes, it is subtending an angle at the pole here, which is equivalent to that. If we are to allow this one to reach up to the pole, okay, so that will be now having the 0.5 here over the distance of 100, and then that will give us that value there. Let's meet in the next session.